Telescopes are the most vital tools of astronomy. They improve the ability of the human eye to see and enable the processing of images and data and their storage for future generations. Historians have recorded the invention of the telescope around 1608 AD by the Dutch lens maker Hans Lippershey. But it was the Italian physicist Galileo Galilei who first built the telescope. Since then, telescope technology has made great strides. The most important of these developments was the introduction of mirror-reflecting telescopes, the basis by which the telescope can be moved in sync with the motion of stars, spectroscopy to analyze the traces of chemicals in starlight, and photography to prepare permanent documents of observations. In recent decades, computer guidance technology in space observatories have greatly expanded the boundaries of telescope technology. Let me give you a brief history of telescopes. Be with us until the end. 1609 AD. Galileo's first lens-based telescope produced images with triple magnification. But later, designs improved quickly. Galileo used his telescopes to make important discoveries. Like mountains on the moon, sunspots, and countless stars that were invisible to the naked eye. 1673 AD. One way to improve the telescope's magnification was to use larger lenses at longer distances from each other. In the mid-17th century, this method led to the construction of giant aerial telescopes whose lenses hung from an open framework that was 31 meters long. 1668 AD. English mathematician and physicist Isaac Newton designed the first telescope to use a concave mirror instead of a lens to collect light. This achievement made it possible to design much more compact telescopes called Newtonian reflections. 1781 AD. In the late 18th century, English astronomer William Herschel developed new metals for his reflecting telescope mirrors. This achievement provided Herschel with the best telescopes ever built and helped him make discoveries, the most important of which was the discovery of the planet Uranus. 1845 AD. An Irish astronomer named William Parsons built a giant reflecting telescope with a 1.8-meter mirror at his private mansion in Ireland. The telescope could only target limited directions from the sky, and the reason for this limitation was the walls built to support the telescope. For more than 70 years, it was the largest telescope in the world. 1917 AD. The Hooker 2.5-meter reflecting telescope at the Mount Wilson Observatory was the first telescope to combine a giant mirror with a maneuverable installation. Until 1949, it remained the largest telescope in the world. It played a key role in discovering the expansion of the universe. 1933 AD. American physicist Carl Jansky discovered radio signals from the sky associated with the rising and setting of the Milky Way in the sky. This finding marked the beginning of radio astronomy. Due to the long wavelength of radio waves, producing high-quality radio images requires a significant collector level. 1949 AD. In the late 1940s, American astronomers used German V-2 missiles to send electromagnetic radiation detectors on short trips across the Earth's atmosphere. These instruments confirmed that the Earth's atmosphere does not transmit space radiation such as X-rays. 1949 AD. Astronomers have long known that observation from high altitudes helps to escape atmospheric turbulence and reduce its destructive effect on starlight. But it was not until the second half of the 20th century that observatories were built on the high peaks of remote mountains. 1970 AD. The launch of the first X-ray astronomy satellite, Uhuru, ushered in a new era of space astronomy. Space astronomy is the study of the universe at specific wavelengths, including X-rays, ultraviolet, and infrared. And because the Earth's atmosphere prevents these wavelengths from reaching the planet's surface, there is no way to know these wavelengths other than sending satellites. The 1980s. Since the middle of the 20th century, the heavy weight of traditional integrated mirrors has prevented telescopes from growing in size. But from the 1980s onwards, advanced engineering advances made it possible to build huge telescopes. The key to achieving massive mirrors was connecting and aligning smaller honeycomb mirrors to mimic the performance of a single reflector surface. 1990 AD. The idea of placing large visible telescopes in the Earth's atmosphere to take advantage of the ideal observational space conditions has been around since 1946. The ability to repair and upgrade Hubble Space Telescope equipment in Earth orbit has made this valuable tool more than a quarter of a century old. Although the Hubble Space Telescope looks dwarfed compared to today's ground-based observatories, its unique location makes it possible to capture mesmerizing images and revolutionary scientific discoveries. 1998 AD. The huge VLT telescope at the Southern European Observatory in Chile consists of 4 separate 8.2-meter reflecting telescopes. This observatory is a remarkable achievement in constructing massive single mirrors that can combine the light of several telescopes. 2014 AD. In the Atacama Desert, Chile, Europe's extremely large telescope is being built, with its main mirror measuring 39.3 meters in diameter from a combination of 798 smaller hexagonal mirrors. The observatory is scheduled to open in 2024. 2021 AD. NASA has been running the James Webb Infrared Space Telescope project for years as Hubble's successor. The telescope's 6.5-meter mirror allows it to see objects deeper than ever. The massive James Webb awning protects the telescope's mirrors and instruments from the sun's heat and disturbing radiation.